Well, habari zenu, karibuni tena. Tuko kwenye session ya mathematics. Tunaendelea na coverage ya topic za form 4. Hii ni topic ya kwanza ambayo actually topic hii ni coordinate geometry. Sehemu ya 5 tutaendelea na distance. Ni distance between 2 points in a plane. And so we are going to dive direct actually to the content, and here we go. We are going to start with this figure. So in this figure, it is actually XY plane. It is XY plane where we were given 2 points, point X1, Y1, and the point Q, which is X2, Y2. And these points are such that the distance PQ is to be determined in terms of X1, Y1, X2, and Y2. So how do we find the distance between these 2 points? Of course, we know that we know the difference. We know this distance from this point to this point here, that is PA. We know that PA is going to be X2 minus X1. And the distance PQA, QA is Y2 minus Y1, because we are talking of this vertical distance here. And horizontal distance, we are talking of this distance here. So as we have seen that PQ can be determined by using point PA and point QA. So and actually line segment QA. From here, we are going actually to use the Pythagorean theorem to determine distance PQ. But how do you do it? In triangle PAQ, by Pythagorean theorem, PA square plus QA square is going to be equal to PQ square. So PA is X2 minus X1 square. QA is Y2 minus Y1 square. And eventually PQ is the distance we are looking, and we're gonna call it actually distance D. So D square. So to be able to find the distance D square, so this is actually D here. D square equals to PQ square, and this is actually equal to X2 minus X1 square plus Y2 minus Y1 square. So to get PQ, you need actually to square both sides. So it's the same as actually taking D equals to square root of X2 minus X1 square plus Y2 minus Y1 square. So you see that this formula is similar to this formula here, and actually that is the distance between those 2 given points. So we are going to generalize. Generally, distance between 2 points, X1, Y1 and X2, Y2 on the plane is given by distance D equals to square root of X2 minus X1 square plus Y2 minus Y1 square. So that is the formula we are going to use always to find the distance between 2 given points. And now let us jump to example. Find the distance between points -1, 7 and 4, -5. So in the solution, but we are going to assume that we'll be taking minus 1 comma 7 as x1 y1 and 4 comma negative 5 as x2 y2, and we are supposed to find the distance. So distance, according to the formula we have, distance is square root of, we have x2 minus x1 square plus y2 minus y1 square. So we're going to plug actually the value of x2, x1, and also y2, y1. So x2 is 4. So 4 minus negative 1, then square, plus y2 negative 5, minus 7, then square, then under root. So distance d, dear students, will be square root of, we'll be having actually 5 square plus negative 12 square. And this is going to be square root of 169. So distance d will be actually 13 units, dear students. So we are supposed to find the distance between 2 points. And so the distance between 2 points is going to be 13 units. Therefore, the distance between the points is 13 units. And let us jump to example 1.1, and this is going to be our second example. Determine whether the triangle with vertices 0, 0, we have negative 6, 8, and negative 14, 2 is equilateral, isosceles, or scalene triangle. So you need to know equilateral triangle. We are talking of a triangle with all sides equal and also all angles equal. Isosceles triangle, this is actually a kind of triangle with 2 equal sides, and base angles of the triangle are also equal. Scalene triangle, this is a triangle whose sides are not equal and even their angles are not equal. So to solve this question, the students, we are going to check distance. I'll be looking for OA first, and OA, that is going to be actually square root of, because we know distance formula, so it'll be 0 minus negative 6, 0 minus negative 6 square plus 0 minus 8 square, and this is going to be equal to square root of 36 plus 64. So OA will be equal to 10 units. And we'll be checking for OB. OB will be equal to, OB will be taking square root of 0 minus negative 14, negative 14. So 0 minus negative 14 plus 0 minus 2 square. So this is going to be equal to square root of 196 plus 4. We have square root of 200, which is actually 10 square root of 2 units. Okay. We're going to find the third distance. And the third distance is going to be at the first side, which is AB, of course. So AB will be equal to square root of, you have negative 60 minus negative 14 square plus 80 minus 2 square. This is similar to taking the square root of negative 60 plus 14 to be actually 80 square, which is 64, plus 60 square, which is 36. You get a square root of 100, and actually this is equivalent to 10 units. So as you can see, two sides are equal. From this, we see that since AB equals to OA equals to 10 units, triangle OAB is isosceles triangle. Triangle OAB is isosceles triangle. So that is solution for example number 2, where we were supposed to show whether given triangles are isosceles triangles, or they are actually they are equilateral, or they are scalene triangle. And we jump now to the last example in this session, dear students. So the last example, we can see from the documents, find the coordinate of the point P on the y-axis, which is the same distance from point Q 3,4 and R 1, negative 2. So the most important part, you can sketch the real diagram where you can actually allocate the points as required actually from the question. With this question now, point P is such that the distance PQ is equal to distance PR. Okay. So we need to find actually this distance. So what is PQ? PQ will be square root of, so be taking 0 minus 3 square plus y minus 4 square. And actually this is going to be equal to square root of 9 plus y minus 4 square. So that is the first distance, and we are coming now to PR. PR, you'll be taking square root of, I'll be taking square root of 0 minus 1. Okay, 0 minus 1 square plus y minus negative 2 square. You simplify this further, you'll be getting actually square root of 1 plus y plus 2 square. So the next step, we are going to compare these two equations. So comparing these two equations, we know that PR equals to PQ. So you have a square root of 9 plus y minus 4 square. This is equal to square root of 1 plus y plus 2 square. So you're going to square both sides actually. And when you square both sides, so you'll be squaring here, and actually you're going to square in there. And when you square, dear students, what comes now is you'll be having actually 9 plus y minus 4 square equals to 1 plus y plus 2 square. You expand, this will be having 9 plus y square minus 8y plus 16 equals to 1 plus y square plus 4y plus 4. So collecting like terms, when you collect like terms, actually y square and the y square will be going. So you have 9 plus 16, it is 25. 25 minus 1 plus 5, so minus 5. This is going to be equal to 4y plus 8y. So when you simplify further, you'll be having actually 20 equals to 12y. And the value of y will be equal to 20 divided by 12. By 4 will be 5, by 4 will be 3. So the distance, the coordinates of point P is going to be 0, 0,5 over 3. That is the coordinate of point P. As you can see, this is coming from here. You have 20, 25 minus 5. You have 4y plus 8y. That was 12. And eventually, we got now the coordinate of point P, dear students. So that is solution for question number 3. This was actually example 3. And that is all for today's discussion. You can dive into other questions. You are going to find actually similar questions where you're supposed to apply the distance formula. And when you apply the distance formula, eventually you'll be able actually to do all the questions. So that is all for today. Again, if it is your first time to be here, consider subscribing to the channel so that you're going to be updated. You're going to be updated actually on the other coming content. I wish you all the best in your mathematics learning journey, and see you in the other coming sessions. Kwaherini.